Now, let us see how we design vector control options from whatever options we have. Now, what is the importance of vector control? Why we should do vector control? So, there are two important aspects. One is vector control aims at prevention of infection, aims at prevention of infection or prevention of transmission. So, when the mosquito bites, it is bound to take the malaria parasite or the filaria parasite or the virus. So, that is called the gain of infection. So, the vector control will reduce the gain of infection in the vectors if vector control options are there. On the other side, parasite control, say for example, mass drug administration, anti-malarials, these are all curative. It increases the loss of infection and also reduces the gain of infection. The parasite burden in the community reduces over a period of time. So therefore, there is loss of, there is a reduction in the gain of infection. When the mosquito again bites that community, the parasite it will not be taking. If it was taking 100 parasite, now it may be taking 10 parasites. So gradually this will reduce over a period of time. So this is parasite control is mainly the reduction of parasite burden in the community. Whereas the vector control aims at prevention of transmission, interruption in the transmission. Now where to consider vector control? Which situation? So the control of vector-borne diseases where no drugs or vaccine is available. Then interruption of transmission areas with drug resistance, where you have a lot of drug resistance problem. So there we can adopt full-scale vector control. Then during disease outbreaks and epidemics. Then to prevent epidemics or reintroduction of malaria or vector-borne diseases from one place to another. So where you have high death rate and morbidity. So these are the situations where we can consider vector control. Now let us see some of the definitions. What is vector control? Is any method which limits or eradicates the vector population that transmit disease pathogens. The principal objective of the vector control is the reduction of morbidity and mortality by reducing levels of transmission. So there are 4 ways to do it: selective vector control, integrated vector control, comprehensive vector control, and integrated vector management. Now we will see in each of the slide what is selective, what is integrated, what is comprehensive, and what is integrated. Now let us see what is selective vector. Selection of certain methods which you know that is efficient at low cost and takes into account the local situation, which is compatible with the local situation. They are applied to certain targets, certain specified targets. So it is called site-specific targeted approach, and it is cost-effective. So such an approach is called selective vector control. Now what is next is integrated vector control. So now here we utilize all appropriate techniques and management techniques to bring about an effective degree of vector suppression in a cost-effective manner. So there is a careful integration of several control techniques in such a way that they do not oppose each other. Each tool will complement each other in optimal cost-effective control, which is achieved for over a long period of time than a short-term solution. It's called integrated vector control. Now, what is comprehensive? Control of vectors of 2 or more vector-borne diseases through an unified managerial structure. So we have a unified managerial structure. For example, your NVBDC setup is a unified managerial structure where there are approaches for control of 2 or more vectors for 2 or more diseases, vector-borne diseases. So such an approach is called comprehensive vector control. Now, integrated vector management is a rational and a decision-making process for the management of vector population so as to reduce or interrupt transmission of vector-borne diseases. So the main characteristic features of this integrated vector management is that the selection of methods is based on the knowledge of the local vector biology, disease transmission, and morbidity. Utilization of a range of interventions often in combination and synergistically, where the collaboration of the health sector and with other public and private sectors, which are having a are responsible for vector breeding, they all become stakeholders, and we have to collaborate with such sectors. Then we have to engage the local communities and other stakeholders. Then we have a public health regulatory and a legislative framework. So under this, when we do a vector control operation utilizing different techniques, then it becomes an integrated vector management. Now, what are the key elements of integrated vector control, integrated vector management is there should be a robust advocacy, social mobilization, and legislation. Then the second most important is collaboration with the health sector and with other sectors. Then there is an integration of all these sectors. Then there is an evidence-based decision making. Then there is another component called capacity building. There should be enough trained manpower for doing all this, who are all vector biologists, who have an understanding of the mosquito biology. So this is capacity building or human resources for such an exercise. So these are the key elements for integrated vector management. Now, what are the vector control options in front of us? So personal protection at an individual level, we can have repellents, we can have insecticide-treated nets or LLINs. The chemical control which the program is doing is IRS, space spraying, chemical larviciding. The biological control is application of larvivorous fishes, guppies, gambusia, biolarvicides like BTI, then environmental management, modification and manipulation. Then personal protection from vector contact is, what do you mean by personal protection? It is defined as the protection of a human at an individual or a community level by using or by adopting measures that do not normally interfere with the birth or death of the vectors. They are simple to use, not so expensive, give protection for more than one vector. It can be applied without health workers' help. So this is called the protection, the personal protection. Now, next is the repellents. The traditional way of repellents is in villages we might see people sitting around a smoke, or smoke is open, keeping burning aromatic plants like chrysanthemum and Vitex neguda, then use of vegetable oils. Then we have now synthetic repellents like topical application, creams, lotions like Odomos. Then we have coils, production of smoke, vapor, aerosol, having alethrins. Then we have insecticide-treated mosquito nets, clothes, curtains. So they are all repellents. Now the advantages of repellents is useful when other protective measures are less effective, impractical, or prohibited. Useful for the people who must be outdoor, who work outdoors. Plantation workers at risk during daytime, or people crossing, approaching areas infested with mosquitoes and other arthropods. Travelers often favor repellents as they are easy to carry and use. Then the other is the bed nets. Bed net is, everybody knows a bed net, an insecticide-treated net, or a simple bed net. It acts as a physical barrier. It prevents man-vector contact. It prevents the mosquito vector biting the man. So what is the disadvantage of simple barrier nets? Hungry mosquitoes are still there to feed. It is only for a short time you are protected by a net. Unprotected person sleeping nearby will become the target. The mosquitoes feed on the body parts, touching the nets while sleeping. These are certain limitations. Now, what is the advantage of LLIN or insecticide-treated nets? It irritates or kills mosquitoes on contact, prevent them finding openings. Next is, it makes the mosquitoes so disturbed that they are unlikely to attack again. Then offer protection to people who sleep outside a net but near someone with a treated net. Then it protects the vulnerable groups, say for example the marginalized tribal community who are poor. So such people are very vulnerable, they are malnutrition, weak. So the insecticide-treated nets prevents the vulnerable groups from acquiring malaria. Then besides controlling the vectors or killing the vectors, They also help in killing the other biting insects like bed bugs, head lice, chicken ticks, house flies. So therefore, the community acceptance is enhanced by using ITNs. They get not only benefit of getting prevented from mosquito bites, they also get added advantage like they are not bitten by other bed bugs, head lice, and other insects. Now ITNs, the main implementation constraint is achieving the coverage. Almost more than 80% of the community should be holding the LLINs. Then it should be acceptable to the community. Then the compliance to appropriate use. The net has to be used in a proper way so that the mosquitoes don't enter the net or do not bite. So compliance to this, then access to nets and insecticides, then retreatment. So these are all the implementation constraints. But now over a period of time, we have overcome all this situation. For example, Orissa is doing wonders. They have been able to cover more than 90%, 95% of the community. As a result, malaria has almost crashing down there in the state of Orissa. Now the next is long-lasting insecticidal treated nets. It gives long effect as the lifespan of the net. Say if the net lifespan is around 3 years, for 3 years the insecticidal effect will be there. So the retreatment is not required and it is wash resistant. So mosquito net becomes the vector control tool when they are treated with insecticide. So when most of the people in the community use them, it produces a mass killing effect in the community. Now let us see some of the chemical control methods. So on the left side you see class of insecticide and the examples for it. Everybody will be knowing in the program petroleum oils and derivatives like malaria oil, organochlorines, DDT, cyclohexane and dieldrin, organophosphates like malathion, temiphos, fenthion, carbamates like propoxer, carbonate, pyrethrum and synthetic pyrethroids like pyrethrum extract, deltamethrin, insect growth regulators like dimilin, methoprene, pyriproxyfen, biolarvicides like Bacillus thuringiensis. The utility of chemical control methods in vector control, the major objective is to prevent or control the vector-borne disease transmission. That is to interrupt the vector-borne disease transmission. So what are the methods used is indoor residual spray, space spraying indoors and outdoors, larval control, insecticide-treated bed nets or LLINs and other protective materials, usage of repellents. The advantage of chemical control is, the principal advantage of chemical control method is that pesticides can be quickly applied with minimum effort. So as a result, manpower is saved, relatively low cost. We get immediate results. Chemical insecticides usually give immediate control of either larvae or adult. Can be applied before vector is observed. Therefore, we achieve an effective interruption of transmission. What are the advantages? We'll see the continuation of the advantages. Chemical control has considerable advantages in situations where environmental and biological methods are not feasible, uneconomical or only partially successful. Where other methods are not possible, chemical control becomes the predominant choice. So the availability of several formulations and applications. So there are a lot of options to choose from. So mostly used in outbreaks or epidemic situations with high density of vectors. Now, what are the different methods? Indoor residual spray, where to use large number of structures with adequate sprayable surface. Majority of the vector is endophilic and endophagic. Vector is susceptible to the insecticide. IRS may reduce the vector longevity, the vector density, number of infective bites. Now, how will you select an insecticide? So it is based on the resting behavior of the mosquito. If you are going to use IRS and when the mosquito is exophilic, then there is no use of this IRS. So that's why the resting behavior of the local vector species is important. So duration of the residual effect, it should be having a long residual effect. It should not have a very short residual effect. So then there is no use of this insecticide. Then it should be safe. Then the local vector should be susceptible. Then it should be cheap, cost effectiveness. Then it should also be susceptible, the vector should be susceptible. So we should be using this insecticide for management of resistance. The other factors include acceptability by the community, odor, visibility of spray deposits, efficacy against nuisance pests. Now, where to use? In epidemic situation, vector shows exophilia, isolated resting area from human habitation, indoor application restricted to conference halls, airports, and other public utility places, may cause drastic reduction in adult density, infected insects dispersal. Then larviciding, where will you use? It is basically used in confined and accessible breeding sites within the vector flight range. Now, what criteria we will use? It should be again effective, cost effective, it should be cheap, and it should be safe to the environment, it should be safe to the non-target organism. It should not kill the other useful insects. Now, the advantage is destruction before being dispersed. So, in a habitat, you will have lakhs and lakhs of mosquito larvae. After a stretch, it is killed. By the time if they become adult and then you want to kill them, then the probability of control becomes little weak. That's why destruction before being dispersed, availability of many larvicides. We have a different choice. Main limitation is here, since the larval duration is around 7 to 8 days, so it requires weekly application, which means frequent application. And its effect on non-target organisms. Certain larvicides can have effect on the other non-target organisms. So generally it is restricted to confined habitats, not to big habitats. Now, where do we use biological control? Where it is the only feasible alternate, where no other approaches are possible, where you can see biological control can be used. So there you use biological control, where it complements the other control measures and to manage insecticide resistance. So in an area you have insecticide resistance, all the insecticides used are resistant, then you think of biological control. Where chemical methods are prohibited or unacceptable. Advantages: it is safer to non-target organism and environment, suitable for community use with little or no supervision. So these are the fishes which all of you are aware. The Gambusia affinis, which is called as mosquito fish, it is exotic fish used in India since 1928. It is a surface feeder. It can feed to around 100 to 300 mosquito larvae per day. And on the figure on the right is Poecilia reticulata, which is guppy. It is also an exotic fish introduced in India in 1910. It is also a surface feeder. It feeds at a rate of 80 to 100 mosquito larvae per day. It tolerates high degree of organic pollution. And it can be used in the polluted habitats. What is environmental management? It is one of the important components in any vector control program. Though initial investment is high, if we link it to the developmental activities, it becomes cost effective in a long run. So this has additional benefits like land reclamation, afforestation, housing, increase in agricultural production, water conservation, etc. Environmental management. Permanent measures, filling of abandoned wells, closing, screening or covering of breeding sites. So these are all called as environmental modification, which is permanent. On the other hand, we have manipulation, which are only temporary measures. Say, for example, desilting, sanitation, which you remove the debris and make the water flow, removal of vegetation, flushing streams, they change the salinity of water, changes in the water level, shading of ponds, straightening and deepening the shorelines. So these are all temporary measures. Now, finally, this summarizes the control options in front of us based on the life cycle of the mosquitoes. Now, on the picture, if you see, the Anopheles mosquito lays eggs. So, oviposition is the act of laying eggs. Now, the Anophelines prefer vast area of breeding sites. So, where ovicide traps is not applicable, not possible to kill at that stage. So, ovi traps is not a possibility. Now, from the egg comes the larvae. Now the larval control is applicable. It can be amenable. It is, we have a range of chemical insecticide. We have different mechanical approaches. We can have different environmental management manipulation techniques. We have biolarvicides. We have fishes, environmental management. So this is this stage could be considered for control. Now, once the larvae has become pupae, then they become airborne. Then the emerging adults, they become male and female, they copulate, they fertilize. Then the females are search of feeding man and cattle. So once you have to save from adults means you have to adopt personal protection measures like nets, insecticide-treated nets, personal protection like so many other methods which I told. And the other way is zoo prophylaxis, where we keep the cattle in the periphery of the village so that instead of attacking man, the mosquitoes will feed on the cattle. Then the mosquitoes after feeding will rest indoors and outdoors. Then you have indoor residual spray and space spray to tackle the resting mosquitoes. So this is in short the control options which we have. Now, what is the criteria for selection of vector control options? It is based on our priority, local needs, and the resources available and the existing infrastructure. And it should be safe, cost effective, simple to understand and for use. By using these tools, we should be able to influence the community and we should get community involvement for the success of the vector control operation. So this is this criteria, main criteria for selection of vector control options. Thank you.